All right, we will get started here. Again, welcome to the final session of Applied Day 2022. This is the What's New in Application Development presentation. We'll get rolling with the presentation here shortly, but first I want to give a quick introduction of Applied. So, since 1986, Applied Engineering has been providing high-quality engineering services. We're able to assist at any and all stages of the product lifecycle. So, whether you need help with product design, simulation and analysis, factory design, process automation, or you just need an extra set of hands to get a job done, Applied is there for you. And then we also have our print and image services department, and they can handle large and small scale prints as well as scanning and digitizing services. So, really, whatever you need, Applied fits your needs. During this session, please feel free to enter any questions you have into the questions box, and we will be monitoring them throughout. Um, these webinars today are all being recorded and will be sent out via email. So if you want to rewatch them, you can, or if you want to share them with friends or colleagues, you can do that as well. So yeah, with that, I will pass things over to our presenter this afternoon, Tycho Kalvoda.
Thank you. Yeah, so I am Tycho Kalvoda. You can reach me at tkalvoda at go-applied.com. I'm currently the software development team lead here at Applied and have been with Applied here for about 10 years. I am a full stack developer, so basically I can work on anything from back end databases all the way to the front end and anything in there between. Um, Multiple database platform experience, including mostly Postgres and SQL Server. I have strong DevOps experience and working with a lot of the front end frameworks such as Angular, Vue, um, any of those kind of big ones that are out there. And today, we're going to talk kind of what's new in app dev. First, I'll kind of just start out in, what are the challenges of modern app development. One of the big issues that we face today as developers is there's just so much choice out there. There's new frameworks popping up all the time. Um, Old ones kind of falling off to the wayside and everything like that. And how does Applied handle this? How do we manage that? And one of the big things that our software team development team here at Applied, including myself, really concentrate on is we look at any new framework or anything like that that comes out. First, how long has it been around? Is it fairly stable? Is it anything that's production ready? As I had mentioned, there's new frameworks and everything coming out seemingly every single day, especially when it comes to front end networks. So it takes a lot of work and investigating to find out what exactly works and what will work best for our customers, because design requirement by one customer isn't necessarily going to be this exact same as from another one. So you kind of have to go and figure out what's going to work best for each one. So some of the topics today that I'll be covering are the .NET Unification, .NET MAUI, .NET Blazer, GRPC, Containerization, development environments, and DevOps. We are primarily here at Applied, a .NET framework shop, so we tackle kind of mostly all that. But we are also experienced in other realms and can definitely take on anything that kind of comes across. So to first kind of start off with the .NET Unification, the .NET framework has been around for roughly now about 20 years. And the problem with it being .NET framework is it was always limited to just um, Windows systems. So you always had the issue of if you wanted to do anything on Linux, because Linux is cheap and it's primarily the largest one used out there for web services and anything like that. So .NET was missing a huge market share there because of that. So a couple of years ago, Microsoft decided to release the .NET Core. .NET Core was taking basically the core elements of the .NET framework and converting them to use as a cross-platform um, framework that you could use, on Linux, Mac, Windows, and pretty much anything like that. That you could take that, write code, and deploy it over across all platforms, which was, at the time, one of the big strong suits of Java, which was that you could do that. So, .NET wanted to take that on. So they came up with .NET Core. Well, now they had the problem of they were maintaining two very large frameworks, .NET Core and the .NET Framework, and they had only a very small interoperability, and that was with the .NET Standard. But that was just some primary libraries and anything like that that you could do some models with and stuff. But beyond that, you pretty much had to write code twice to use on both. Um, so with .NET version or .NET Core version 3 and .NET Core version or .NET Framework 4, they decided, you know what, at .NET 5 we're going to merge the two together and just go from there and deprecate both previous networks or .NETs and use them from there. So when .NET 5 came out about 2 years ago, that was the first iteration that had included everything all together and did not have absolutely everything that they wanted from the .NET framework, all the different libraries. Namely, WPF was left out, as well as the WCF. But this last year, .NET 6 came out, which kind of grabbed all those stragglers and pulled them all into the project, with .NET 7 coming out this year and having even more of those items in there. And most projects these days can be converted. It really just depends. Anything that's WCF was never meant to get moved over to .NET Core or the .NET 5.6. However, there have been third parties that have been working on and deploying that and getting that up and ready. So there's definitely some hope there for those. But if you have anything that depends on comms or anything like that, most likely it's not going to go beyond the .NET Framework 4. So this is a fairly huge thing, especially because now it gives people and companies a larger variety. They don't have to run it on IIS. They can run .NET on anything pretty much, and so a lot more options out there for people. The next one that I'll talk about is .NET MAUI. .NET MAUI is a cross-platform application development, and it's primarily made for Windows, Mac, iOS, and Android. And if you've ever heard of the Xamarin project, which was originally taking C# and deploying it to iOS and Android and having a small code base overlap between the two, this is the next evolution in that entire project. And this one also wraps in Windows and Mac as well, so you can take your desktop app and transfer it over to Android or iOS. This is a modern framework. Its first release is slated for this month. However, obviously with development, it always never hits necessarily its release time. But so as of now, it's very much in its release candidate 4 to get ready to go. Pretty much any of your development can be done now on Windows. If you do want to deploy to an iOS device, you do need a Mac, because you do need Xcode to run anything with that, anything Mac related or iOS related. With that, I can give a little demo here, kind of what they deploy to. And so this, you can see up here, I am targeting a Pixel 5 emulator that I've got running. So then this can just basically show once it compiles here and runs. And this will show how you can take the same code base, compile it differently, and run it on multiple different architectures and layers, and it will automatically render it correctly. And something for like Android and iOS, this is a full native app. It's running binaries and everything. It's not like a lot of the other things which um, run in a web view and then everything. This is a literal Android button that you're clicking and everything like that. It compiles down. So you still get that speed benefit and everything that you get with Android. And then now I can take this and switch over to the Windows machine and run the exact same thing, and deploys a Windows app that you can now also run on your desktop. So there will be some small amounts of code that need to be duplicated across the thing, but it's up in the 90% point that the code can be shared between all the different projects, which is pretty significant considering how much time gets spent rewriting the same app for different platforms. And here you can see the same thing, and each one is programmed to automatically pull in the default environment, so that's why it's dark on this one. But same thing, the button clicks and everything. So it's really a very rich app that we can now use and deploy across multiple systems while saving the customer money, because we don't have to rewrite this several times in order to do the same thing. I'll jump to the next slide here. NetBlazer is the next kind of iteration of the ASP.NET framework. You have, and ASP has been around for quite a long time as well as .NET, ASP.NET, and the MVC framework. And this is just another example of a framework. One of the big benefits of this, of NetBlazer, is it's both server and client-side frameworks are available. So you have .NetBlazer Server and .NetBlazer WebAssembly. And the big thing with this one too is we're pulling less and less JavaScript, or putting weight on JavaScript, as Blazor is able to do a lot of the DOM manipulation that JavaScript has been the workhorse of all this time. So it's both quicker and more modern and everything. And I'll show a quick demo on those two. So first we'll kind of do the WebAssembly. So the WebAssembly, the difference here is your entire app that you deploy is going to be downloaded to the client's computer and is going to be ran in kind of a sandbox on their computer, still with the same protections and everything like that. However, you don't have the lag of running any, calls back to the server to re-render anything like that. The only downfall is you obviously have it's going to be a more heavy download on the front end. So when you first run it, it takes this little bit more where it takes and loads, because it's downloaded the entire app and running it. And so here we go. You've got the thing here. Now all this rendering is done on the client side. It's doing all the C# code. Everything is being done on there rather than bouncing back to the server to have to grab any of this value or anything like that. And I'll switch over to a Blazor app server. And now this is going to be more like your classic ASP or ASP.NET and MVC. All the pages are still rendered in the Razor format, so you have the same thing that's been around for 10 plus years, but just updated basically to allow for this. And so we'll run this here, and now you can see it loaded instantaneously, whereas the other one had to download the application, whereas now we're just grabbing it in this way. Same thing, counter, everything the same. So definitely something that we are looking into and looking to implement when we need to, because it definitely has its benefits over the other technologies, especially if it's something smaller that you can run on the front end and do just a single deploy web framework to it. GRPC is really starting to become a big player in the data connectivity transfer type realm. It's an alternative to the REST services, which is, basically you call a URL, send it to the server just sends it back, and you got your result. One big thing about gRPC is it allows for bidirectional feeds. So you can have a connection remain open, and you can sit there and keep sending data to the server while the server keeps sending data back. You don't have to send, receive, start a new connection, send, receive, start a new connection. Um, it also allows for streaming of data. So if you have a server that's running through, say, a list of data points or anything like that, rather than taking that entire list and having to ship it over all at once, the server can now send each individual item in that list every single, anytime it's ready to send, it can send it. The front end can render it or do whatever it needs to do with it and wait for the next stuff and just keep doing that. So your front end user client experience is a lot smoother and flows a lot better. Um, One of the big things with gRPC is that it uses binary data rather than text, such as JSON or XML or any of those that have gone before. Um, with that, you're saving a ton of space because you also, with any of the older, or with JSON or XML, you have to send along the model of what the representation of what that data means. So you have to have key value pairs, anything like that, so that you can describe the data. Whereas since gRPC is binary and uses what's called protobuf, it can it already has the model of that, and it only has to send just the data. And I'll show a little example of what a protobuf file looks like. Um, gRPC also uses the latest HTTP2 and HTTP3 when available. Um, so it has the best connections possible and most efficient, that have been made so far. It is also language agnostic. So you write these protobuf files once, and then you can compile it to whichever language you need it, whether it be C# or Go or any of those. And here we can see just a very simple protobuf example. And essentially, you can define, that you have a greeter service that has a remote procedure call called say hello, and a hello request, and that takes in a hello request and sends back a hello reply. And then you define those messages down below, and this is what allows it to just send just strictly the data, because your endpoints are all going to have these protobufs compiled into their language and know exactly how and what to do with those specific files. The next one is, and this is probably not necessarily new, but it's getting new stuff all the time, would be the containerization. This is basically a step above using virtual machines, whereas virtual machines, you're taking an operating system and installing it onto an existing operating system and running an entirely new operating system on it, and within its own isolation and everything like that. So containerization kind of takes that a step further and says, well, instead of using that OS for each individual one, let's use the common OS on the host system, and we can use all the kernel and all those calls and do everything on that sub level, and then just pass into an isolated environment of these containers. They get to have their own volumes there for their data and everything like that, so they can stay isolated and keep like that. What this really allows for, especially on the development side, is very quick setup times. We have one big challenge with either starting a new developer or starting a new developer on a new project is even getting them set up for that project, because you need to install this SQL server, you need to do this, you need to do X, Y, Z. There's some projects where it took a day just to get a developer, their computer even ready to run something specific. So one thing that Applied has been doing is anything that we start new or anything old that comes up and could use it, is we convert those applications into a Docker environment or a containerized environment. And what that helps us with is we can get those up and running much quicker whenever we need to bring someone on. Um, and that the basic one there is Docker, and that helps us do that. there's two main players right now in containerization, Docker and Kubernetes. Docker is very much more for the development side of things. They used to have Docker Swarm and stuff like that, which was kind of a light version of Kubernetes. However, they sold that part of their business off because they wanted to just concentrate on developers and making that system the best. Kubernetes was developed by Google as a system for managing the massive amounts of services and stuff that Google offers. And Docker is fairly quick and easy to learn, especially the very lightweight stuff of it. Whereas Kubernetes is a very complex beast that it takes quite a bit. There's so many parts to it, especially since you're managing typically enterprise grade things and scalability and such. And so just to do a quick demonstration on how easy it is just to get started. So to get a simple web service up and running, this is using Nginx, and which is a web service slash reverse proxy and load balancer. But it also just serves as a great example to run a simple web service. So here I'm doing Docker run. I'm telling it to create a new container. The --rm just basically, hey, I want to remove this. Whenever I'm done, exit out of this, remove that container and destroy it. The -p is to publish the localhost port of 8124 to port 80 on the container. So on my localhost is mapping to the port on the back end, and I just know 80 is the port that Nginx happens to use. So we can just fire that off, and you can see I've already got the image downloaded, so it goes pretty quick to get that. And then you can see on here, and there we go. We've got a Nginx server up and running pretty darn quick. And you can see here, you can see on the container that, so Docker, I'm checking how many containers are running. And here you can see that it's up and running. And then I can stop it as well pretty easily. And that just sits there and it'll stop that container. And obviously destroy it right away because I had told it to remove it right away. And there you can see it stopped that command, and now it has also gone away on the server. So it already destroyed and gone. So it makes for quick, easy setup and deployment of things. Dev environments are another very large thing that's coming down the pipeline. This is primarily with VS Code. It uses containers as the development environment. So again, as applied as we work on multiple projects at once, sometimes it's hard to keep those kind of separate and running, especially if they're using common database servers and anything like that. Well, this kind of isolates it one step further, and as well as now, instead of having to have a document in your folder to say, oh, you need this extension for VS Code, you need this extension, you can just define those in there. When you set up and run this development environment, it takes it and starts it, installs any of those extensions that are needed, and you're ready to go, and everything is good to go. I'll do a quick example of that using VS Code. The VS Code has made it super easy. You just go to your command palette and you can do remote containers, try a remote container, and I'll just pick Go language. You don't even have to have the Go language installed on your main computer. Again, it'll take care of all of that. The first time it runs does take a little bit of time. I've ran this before, so it goes a little quicker. But basically, it's getting that environment all ready to go, and grabbing the Git image from GitHub, and just taking a few seconds. There we go. It sets up port forwarding and everything like that. So you can see here within the dev container JSON file, It's already said, oh, yep, you need the golang.go extension installed so that your development environment is all ready to go. It's already got the debug thing. So all that I have to do is hit F5. And you can see it's already up and running on that port. So we can just go to localhost 9000. And you can see, hello Tycho, it's already up and running and ready to go for an app developer to try out. So very quick, very efficient, and makes developing a much less frustrating thing to get even just started. And then now you can exit out, and it completely exits out of that environment, and now it goes back to regular. In the DevOps world, the next topic, in DevOps, we've got CICD, continuous integration, continuous deployment, where, again, been around for a little while, but especially with the Dockerization and containerization of everything, things have become to the point where it's so easy to set up these environments to run tests so that when you deploy to a production branch on GitHub, you can have it set up to automatically run every single test. And once that all those tests pass all for integration tests, it can move it on, deploy that code out to your production site, and a lot of the things come out of the developer's hands and everything. Kubernetes front ends, there have been, as I had mentioned, Kubernetes is a pretty hefty beast to try and learn. There have been multiple tools. Rancher is the one that I've really started to like. I'll show a quick little example of how easy it is to use compared to, anything, what it could be, on the thing here. So here you can see I've got a cluster, Kubernetes cluster. This is my Raspberry Pi. I have about 4 Raspberry Pis all networked together using Kubernetes. And you can go see, you can see all the different nodes. So I've got, 1, 2, 3, and 4 that are running. They're all linked together. And let's say I want to, for example, run an Nginx server on here as well. So I can just go to create, and let's just do applied days for the name. And I'm going to tell it right now to do just one replica. So I just want one version of it. Container image, I'm just going to do Nginx. And I'm going to choose node port so that it can handle the requests from that port, kind of the same way I did with the -p. So test ports. And I know the client or the private container port is 80. And then for the listening port, I'm just going to do 31222 and create. And now you can see it's already in progress and running already. So, and you can see there it's running on cluster 4. And then I can simply just click into this, and you can see it's running there on cluster 4. So I'll do cluster 4.local to do the common name. And you can see it goes there. And the nice thing about Kubernetes is Kubernetes has its own internal routing system. So because these nodes are all linked and I have it as a node port, I can go to cluster 1, which I know it's not running on, but it automatically knows and will forward me over to the correct one there. And then let's say, okay, well, maybe I want to try some, heavy availability as well as route management. So I can go to edit config and edit this at any point. So let's say, well, now I want to try 10 and save. And you can see there it's already got 1, 2, 7. So it's already got 10 instances. You can go in there and see, oh, yep, I've got it on 2, cluster 2, 4, 3, and it will automatically do the load balancing for me. So I don't even know which server that's running on. I just know it's running somewhere in those containers, and it's Nginx, or not Nginx, Kubernetes does all the rest of it in the background. And then when I'm done with that, I can just simply click here and delete. So instead of a lot of command line things, these tools just make it so much easier. And there now it's deleted and clearing off all those off my Raspberry Pis. And new tools are constantly coming out. I mean, there's always something new coming out. Uh, and then some of the things, obviously limited time, so I couldn't go over everything, but up and coming things are just continuing advancements in containers. Docker just had their Docker days last week, where they announced some new things. Web3 or the blockchain, not just for cryptocurrency, but it's the blockchain model works great for immutable data such as databases and stuff like that you want to save that data or have it distributed across wider areas. In the areas of data visualization, we have Grafana. That one is beautiful displays that they are coming out with, easy to link up to your existing um, either Redis or anything like that, and can just visualize that data that gets put in there for logs or anything like that. And then stacks. Redis Stack was just announced, I think, last month, and how those are going to change and affect kind of everything and make it entire ecosystems and services that are just existing on one stack and ready to go. With that, I guess, does anyone have any questions that I could try and answer?
Yeah, there is one in the chat here. It says, the concept of GRPC seems to be based on the concept that data meaning is based on convention understood by both ends. Originally, every protocol was that way. Seems like we have come full circle. It was understandable when communications and memory was so limited, but not so much anymore. What am I missing that makes this a good idea again?
Basically, I would say it's the amount of data. So yes, absolutely, that's how it was before, and now it's to the point where we have so much data. I mean, you take a look at some of the data sets. I know we have written some apps where we're pulling, thousands of records at one time. Well, you still have to package that up and send it over. Well, by making it, even at compressing it in any way, shape, or form. Obviously, compressions have their limits too. So if we can remove even another part of that and still have that interoperability where, well, we don't have to rewrite, like it used to be for data transference that each side had to know. You just write it once, deploy it, and you're good to go. And that was always the benefit with JSON and stuff like in XML is the model followed with data. But now we can compile it, have it ready to go, and on both sides, and still save the time of development and save bandwidth. Would be my answer, anyways.
Right, so let me just double check here. Okay, there's another one in the chat. Do you have any tips or newbie advice for people starting out with development?
Ooh, um, you know, I would say is the biggest thing is to develop stuff on your own. That's how I learned a lot of my stuff because obviously when you work for a company or something, you have to do what they have to, and by being able to jump around and do whatever kind of you want on the side, if you have an idea, run with it. Even making just simple inventory apps, for yourself is a great way to expand your knowledge and test and then you can use those same principles for trying out Docker, trying out anything like that. One of my big things is never stop learning.
Awesome. Okay, let's see if we have any others. It looks like it's just those two for now. If anyone else has any other questions, please drop them in the questions box while I give my sort of outro spiel here, and we'll make sure to grab those right before the end. But if there's nothing else, I just want to thank everyone for attending Apply Day this year. We had a great turnout with our 4 sessions. And then once again, each of these sessions has been recorded and will be shared with you via email, and then will also be available on our YouTube channel. So yeah, Tycho, if you have nothing else, I think we can end it.
All right, that sounds good.
Awesome. Thank you, everybody.
Thank you.